A correlation matrix displays the correlation coefficients among numerous variables in a research study. This type of matrix will appear in hypothesis testing or exploratory quantitative research studies, which are designed to test the relationships among variables. In order to interpret this matrix, you will need to understand how correlations are measured. Correlation coefficients always range from -1 to +1. The positive or negative sign tells you the direction of the relationship, and the number tells you the strength of the relationship. The most common way to quantify this relationship is the Pearson product moment correlation coefficient. Mathematically, it is possible to calculate correlations with any level of data. However, the method of calculating these correlations will differ based on the level of data. Although Pearsons R is the most commonly used correlation coefficient, Pearsons R is only appropriate for correlations between two interval or ratio level variables. When examining the formula for Pearsons R, it is evident that part of the calculation relies on knowing the difference between individual cases and the mean. Since the distance between values is not known for ordinal data, and a mean cannot be calculated, Pearsons R cannot be used. Therefore, another method must be used. Most other methods have been derived from Pearson's. Please note that there are also other methods for calculating correlations among more than two variables. Recall that correlations measure the direction and strength of a linear relationship among variables. The direction of the relationship is indicated by the positive or negative sign before the number. If the correlation is positive, it means that as one variable increases, so does the other one. People who tend to score high for one variable will also tend to score high for another variable. Therefore, if there is a positive correlation between hours spent watching course videos and exam marks, it means that people who spend more time watching the videos tend to get higher marks on the exam. Remember that a positive correlation is like a positive relationship. Both people are moving in the same direction through life together. If the correlation is negative, it means that as one variable increases, the other decreases. People who tend to score high for one variable will tend to score low for another. Therefore, if there is a negative correlation between unmanaged stress and exam marks, it means that people who have more unmanaged stress tend to get lower marks on their exam. Remember that a negative correlation is like a negative relationship. The people in the relationship are moving in opposite directions. Remember that the sign, positive or negative, tells you the direction of the relationship, and the number beside it tells you how strong that relationship is. To judge the strength of the relationship, consider the actual value of the correlation coefficient. Numerous sources provide similar ranges for interpretation of the relationships that approximate the ranges on the screen. These ranges provide guidelines for interpretation. If you need to memorize these criteria for a course, check the table your teacher wants you to learn. Of course, the higher the number is, the stronger the relationship is. In practice, researchers are happy with correlations of 0.5 or higher. Also note that when drawing conclusions from correlations, the size of the sample as well as the statistical significance is considered. Remember that the direction of the relationship does not affect the strength of the relationship. One of the biggest mistakes people make is assuming that a negative number is weaker than a positive number. In fact, a correlation of -0.8 is just as high or just as strong as a correlation of +0.8. When comparing the values on the screen, a correlation of -0.75 is actually stronger than a correlation of +0.56. If a researcher was investigating the relationship between several factors that may influence student marks on an exam, the correlation matrix may look like this. Notice that there are correlations of 1 on a diagonal line across the table. That is because each variable should correlate perfectly with itself. Sometimes dashes are used instead of ones. In a correlation matrix, typically one half of the triangle is filled out. That is because the other half would simply be a mirror image of it. Examine this correlation matrix and see if you can identify and interpret the correlations. A great question for an exam would be to give you a correlation matrix and ask you to find and interpret the correlations. What is the correlation between completed readings and unmanaged stress? What does it mean? Which coefficient gives you the most precise prediction? Which correlations are small enough that they would not be of much interest to the researcher? Which two correlations have the same strength? From looking at these correlations, what could a student do to get a high mark on an exam? Comment below to start a conversation. To generalize conclusions from these correlations, researchers need to assume a number of things. Various measures exist to test these assumptions. To interpret the meaning of correlations, researchers also considered a number of other measures before drawing conclusions. Thank you for watching. Please check out my related videos and subscribe below.